Okay, first things first for the math pileup. So starting at the first triangle, going to A, B, and C, we're trying to find the length that is right here. And the way we're going to do that is by using cosine law. So first thing we're going to do, since that we know sides A, the side length of A, and the side length of C, and we know the angle is 111 degrees, we can plug it in to the cosine law formula for finding lengths. So I put 8 squared here, 2.3 squared there, subtracting 2 times 8 times 2.3 cosine 111 degrees. Now we add all that up, we get 64 plus 5.29, and then equaling 36.8 cosine 111 degrees. And when we get that, we have 69.29, subtract negative 13.1874905, and the reason why it's negative is because when this is multiplied together, it comes out to be negative. And once you do all that, it adds up to 82.47994054. And once you square root that, you get x equals 9.08 centimeters. But you're also square rooting x squared. I forgot to mention, you're also square rooting x squared to get rid of the square. So you get 9.08 centimeters for that length. Now moving on to question 2, or shape 2, BCD, we're now finding the length of this. Now since we already know the length of the other side, 9.08 centimeters from that question, we can just plug this in using sine law. Now we know the angle degree of D and the angle degree of B, so we plug that in. We have x over sine 76 degrees, because x is opposite of 76 degrees. We have 9.08 centimeters over sine 78 degrees, because that is opposite to that. Now, to make x by itself, we need to multiply each side by sine 76. And once that is done, we get x equals 9.08 sine 76 degrees over sine 78 degrees. Now once we do that, we get x equals 9.007 centimeters. And when rounding that, we'll just equal 9 centimeters. But for the sake of everything, we're just going to do 9.007 centimeters. Okay, now moving on to the third triangle, angle CEF, or length CEF. We're trying to figure out the length of this side. Now we know the length of the full triangle. One side is 1 centimeter and the next side is 2.8 centimeters. And we know that the bottom length is 10.000 centimeters, 7 centimeters. And the reason why it's 10, because the original triangle also, we're including 1 centimeter here. So that's just adding on to the 9 that we found, which would equal 10.007 centimeters. So we know that. We know the degree of this. Well, once we find, hang on. First, before we start the equation, we need to first find the angle of this, because we need to find the opposite of that. So how we do that, we do 180 degrees, because a triangle, all sides add up to 180. Subtract the 35 degrees that we know here and the 10 degrees that we know there. And once that happens, we get 135 degrees, which can be plugged in and put here. So since we know that, we can use that information to plug in sine law. So as done in the previous question, we have x what is opposite of 135, which we do x over sine 135 degrees, which equals 10.007 centimeters, which is opposite to sine 35 degrees. And what we're going to do is multiply each side by 135 sine, which then gives us x equals 10.007 sine 135 degrees over sine 35 degrees. And once that's all done, it'll equal 12.33 centimeters. And that is concluding adding the 1 centimeters that is here and the 2.8 centimeters here. But if we're just wanting to find this angle, we have to subtract 12.33 by 1 and by 2.3, which comes out to 8.53. So that is the missing side length for that. Now moving on to question 4, we are now trying to find the angle of h. Now the way that we do this is that we are using cosine law, cos theta. So since we know all side lengths, we know that this is 8.53 centimeters, we know that this is 5.7 centimeters, and that this is 4.4 centimeters. We know that since we know the side lengths, we can just plug it in using finding the angle version of cosine law. So we have cos theta, which equals 5.7 squared plus 4.4 squared minus 8.53 squared over 2 times 5.7 times 4.4. Now when we add all things up, we get 32.47 plus 19.36 minus 72.76 over 50.716. Now, when we do add up 32.47 plus 19.36, and then we subtract it by 72.76, and then we have to put that over 50.16, and once we put that into the cos theta, we get negative 0.417264752.791. And since that we want the angle, we have to put it in cosine inverse, which then comes out to 65.33 degrees. So that's the angle for that. Now moving on to the last triangle. So now for the last triangle, for GHI, we are trying to find the angle of H. Now in order to do that, since that we completed all the steps from finding the length of that all the way to finding the angle of this, now that we have completed all that stuff, it should help us figure out what the final answer is. So since that we know that 65.33 degrees equals H, then in order to find the angle, since that we know that when these triangles are put side to side, it equals a straight line, which means that it adds up to 180 degrees. In order to find that last angle, we have to do 180 degrees, subtract 65.33 degrees. Don't worry about that. That shouldn't be there. Now when doing that, it should equal 114.67 degrees, which would be the final answer for angle H. So the angle H should equal 114.67 degrees. So that's the final answer. And now as we can see, we have started from that point, which we got ourselves 9.08 centimeters. Then we figured out the length for this, which was 9.007 centimeters, which then allowed us to figure out what this angle would be, this length would be, which then allowed us to figure out what this length could be, which then allowed us to figure out the angle for H, which then allowed us to figure out the angle for the final triangle. So that is the math video pileup. hope that this is the right answer. All right.